Okay, so for a given triangle with the sides A, B, C, and with the corners A, B, and C, we have the corresponding opposite sides, which are small a, small b, and small c. Why this is so important is because many of your formulas, for example, area of half AB sine c, your sine rule, your cosine rule, requires you to know where these letters are, what they represent. Okay? So for area, we have half A small a, half AB sine C. And what do we say about this angle C? What do we call this angle C? It starts with I. Included. What does included mean? Yeah, it's like in between the two sides, right? So the sides I have over here are A and B. And in between them will be angle C. Look at this side A, side B, and in between them will be angle C. We call this included. So the other variations will be half BC sine A, half AC sine B. Okay, all these, they will give you the same area, they will give you the same answer because the triangle doesn't change. So that is for area. Then we have our sine rule. Okay, so we have A over sine A equals to B over sine B equals to C over sine C. Okay, and we said that there are two cases when we can use them, and they are listed inside your textbook page 74. So in part A, they say you can use this when you have two angles, when you are given two angles and a side. So when a diagram, they give you two angles plus one side, you know you can definitely use your sine rule. And what else, do you remember what else did I say about when you're given two angles in a triangle? You can find the third angle. You can find third angle. And sometimes they require you to do this. It is not so straightforward. You need to find the third angle first before you can use your sine rule. So that is something that they could do to you. Okay, then the second case, case B in your textbook, they say when two sides are given and a non-included angle. Okay, so for example, in this triangle, let's say I give you A and C. Okay, I give you these two sides, A and C, and then I give you this one, angle C. Okay, you're given side A, side C, and angle C. Can you see that this angle is not included inside these two sides? It's not included, right? So this is a case when you can use your sine rule. That's what it means. Okay, moving on to our cosine rule. Again, we have our formula, a squared equals to b squared plus c squared minus 2bc cosine a. Then we said that this a over here, this a over here, they are opposites. So be familiar with the format of your cosine rule. Then what else? I didn't mention the last time. You see this b over here? It is found here as well. So you'll be writing the same number twice. You write it here once, you write it here another time. And then you see, hey, there's actually a third letter, C over here. Right? They appear twice. And then there's a constant of -2. That is your coefficient of BC cosine A. Okay? So when are the cases that we can use your cosine rule? When you have two angles and a side, you use sine rule. When you have two sides and a non-included angle, you use sine rule. So the time to use your cosine rule will be, you're given two sides and an included angle. See the difference between this and this? Okay? When it is included, use cosine rule. When it is not included, use sine rule. Next, when you are given 3 sides, given. Okay? These are the 2 cases when you use your cosine rule. All this is found in your textbook, page 74. There are 2 ways you can do this. Either you memorize all the different types and you apply accordingly, or you practice enough such that you look at the question, you know what you have to use. Okay? It is going to be either one of them for non-right angle triangles. So let us go quickly and take a look at revision exercise 7. We're not going to be doing the questions. This exercise, question 5. What I want you to do is to just take a pencil, think about 5a. What are you given? And what rule will you apply? Okay, so I give you a bit of time to think about it. If you know the answer, just write it down at the side. Form an equation if you have the capacity to do so. Okay, so they want the length of BD. So think about it, what am I given? Of course, you must identify the triangle first. So the red triangle is what I'm interested in. The yellow part is what I need to find out. 5A. Oh, 5BC. Oh, sorry. Find the yellow side, BC. So 5A. What rule should we use and why? Okay, I hear sine rule. 5A, we use sine rule. Why? What did they give you in this red triangle? 2 angles and a side. So because 2 angles and a side. Right? This is found in your page 74. So now, I want you to practice. Write down the equation. What equation will you write? How are you going to form an equation using sine rule for this red triangle? Sophia, are you doing it? Ali, are you doing? Afian, finished? What do you write first? BC over sine 41 degrees equals to 8 over sine 77. Right? Okay. Does anybody has any questions with Alfian's answer? No question. So Ali, I'll ask you the same question I asked you yesterday. Where did the 77 come from? Yes, and what is the reason? Angle sum of triangle. So this 77, like what I mentioned just now, right? When you're given 2 angles, it means you can find the third angle. This will be 180 degrees minus 41 degrees minus 62 degrees. And that will give you 77 degrees. Angle sum of triangle. So what we could have done earlier on will be, we write this down. Angle DBC equals to 180 degrees minus 41 degrees minus 62 degrees equals to 77 degrees. And we say angle sum of triangle. Okay, this is my first step. Then my second step, I will write this down. Please take note, when you write down angle sum of triangle, this one, you cannot just draw a triangle. Cannot. Not allowed. You must spell it out. Okay, so once you have this, you can solve the equation yourself. Okay, so that is where we are going to stop for 5A. This is a practice on how and which rule we should choose. So next one, part B. Okay, we have already found our value for BC. So this is done. Then part B, find the length of BD. Okay, if you decide it is sine rule, write it down. And write down the equation. If you can, tell me the reason why you choose whether it is sine rule or cosine rule. For those of you who have chosen one of the rules to use, think about whether you can apply the other rule. Some of you chose sine, think about whether you can use cosine. Some of you chose cosine. Think about whether you can use sine. In trigonometry, sometimes there's more than one way to do it. So, what did you all choose? Winnie Wong, what did you choose? Sine rule. Okay, she chose sine rule. Is it the two angles and a side or two sides and non-included angle? Based on two angles and a side that is given, or based on two sides and non-included angle? Don't know. Okay, never mind, tell me your equation. Have you written down your equation? Then you just write sine rule, but do you know why? Yes or no? Sophia, help her. Sine rule, why? Come on. You are expected to know this. Afiq, are you able to help? Say again. Two angles and a side. Because two angles and a side. Which are the two angles that you are using? Which are the two angles you are using? Because you say two angles and a side, right? Right now I have three angles. So which two angles are you using? 77 and 62. Very good. So what is the equation you will form? We need to move faster. I have many examples to go through with you, and I need you to work with me. If you're not thinking, you'll be holding everybody up. Then I only can cover a few examples. BD over sine 62 degrees equals to 8 over sine 77. Excellent. One equation, one unknown. Okay? So, anybody chose cosine rule? Anybody? Finding the length of DB. Look, I have one side over here. I have another side. This is found in part A. Then I have, what is this angle called? Included angle. I have two sides, one included angle. So I can use my cosine rule also. Because two sides plus one included angle. So my equation will look like this. dB square equals to 8 square plus answer in A, which I don't know what is it, I'll just call it A square, plus, minus 2 times of 8 times answer in A, cosine 62 degrees. Okay, so from here you can find out what is dB equals to also. So square root, whatever. Which one is easier? Looks like sine rule is easier, less calculation. Okay, next, flip to the next page. I want you to look at question 9a. Same exercise, don't need to work anything out. Look at it, understand, think and understand what to apply. 9a. Find angle ADB. ADB. Okay, finding this angle. What rule should we use? Devina, what do you say? Sine rule. Why? Because we are given two sides and non-included angle. Okay, let's see whether that is true or not. I want to find this, right? So I'm given two sides, one side over here and one side over here. And this angle over here, 110 degrees, also given, but it is not included. So yes, I can use my sine rule. So what is the formula what is the equation that I'm going to form? So like what some of your classmates have realized, it is usually easier to put the unknown at the top. So you have a choice, either you put the distances, the lengths at the top, or you put a sine angle at the top. Right now we are trying to find angle, right? So it is slightly easier for us to put the sine of the angle at the top. And usually we like to put an unknown on the left hand side of the equation. So that is what I'm going to be doing. The sine ADB over sine ADB Did they give you anything else? Oh. Yeah. You cannot straight away find this green angle. We will have to find this angle first. Okay, then after that, we are going to use sum of angles in a triangle. Okay, so change strategy. We are still going to be using a sine rule because these are still given, two sides and a non-included angle. So sine DBA over 35 is equals to sine 110 degrees over 46. Okay, so now we can find out what is sine DBA. Is equals to 35 sine 110 degrees over 46. Meaning I can find my angle DBA is equals to sine inverse, all this without calculation, 35 sine 110 degrees over 46. Okay, then you will get a value equals to something degrees 3 dp. Okay, once I get angle DBA, and then now I can use my angle sum of triangle to find the green angle. So therefore, what they require, angle ADB is equals to 180 degrees minus 110 degrees minus angle DBA, which is from here. And the result will be angle sum of triangle. Answer in 3 dp, round it off to 1 dp. Anybody lost? Alright, then next one, angle CBD. How do we find angle CBD? This one over here. This one is more straightforward. CBD. Which one? Cosine rule. Why? 3 sides are given. So straightforward. I just need a little bit of space over here. Part B. We are going to use the cosine rule. Because 3 sides given. And the 3 sides are 46, 27, and 40. So the challenge right now is to form the equation with these 3 sides. You know your cosine rule has 3 options, right? It can be a square equals to blah 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 blah, b square equals blah blah blah, c square equals blah blah blah. So you need to choose the correct one. And which should we choose? See, I want this angle in purple color. So I shall use 40 square to start. I want to use the angle opposite it. Look, in my cosine rule, the angle is opposite the side. Right? If I want angle A, I must start with the side that is opposite the angle. So bringing this to this example, if I want this angle here, then I must start with 40 square. And the equation will look like this. 40 square equals to the sum of squares of the other two sides. Equals to 46 square plus 27 square minus 2 times of 46 times 27 cosine CBD. Okay, now you have one equation. Solve for angle CBD equals to how many? 3 dp. Then 1 dp. Okay, so that is why I said you must see the pattern over here for our cosine rule. Okay, the first length, all these small letters, they are your lengths. The first length, a square, is actually found directly opposite angle A. If you want to apply your cosine rule, you definitely have one angle involved. And in this case, in my example, angle A is the angle I'm using. So I have to start off my equation with A squared, which is opposite the angle. That is how this cosine rule works. You will see if you try to derive it yourself. You can derive it based on area of triangle also. Okay? So that's how I know I must start with 40 square. So, any of you curious what will happen if I start off with maybe 27 square? Let's see what happens if I start with 27 square. So if I apply my cosine rule with 27 square, what comes next? Shafiq, what comes next? 40, how much? 40 square plus 46 square minus 2, 40, 46. Cosine? 8. DBC. Are you sure or not? BDC, yes. Because he is starting with 27, right? If he starts with the side 27, my angle will be the side opposite 27. And that is not what I want to find. So I've just wasted time doing this. Okay? So knowing which one to use saves you some time. Well, if you do this, then you realize that, that's not the angle I want. Never mind. Go and try again. Try with another side. Instead of 27 square, you can still try 40 square. You can try 46 square. But one of it only is correct. Knowing what to choose saves you time. Okay? So next, question 13a. Okay, how to find the length of BC? Okay, number you don't answer. Irfan, how do I find the length of BC? Which rule should I use? Teja, don't tell him the answer. You must think. Which one? Sine rule, okay. Why are you using sine rule? Because you flip to page 74, then you look under sine rule, you have an A and a B. There are two options for sine rule. You are given two angles and a side. Or you are given two sides plus non-included angle. So which one are you choosing, A or B? Or now you change your mind, cosine, because it doesn't fall under any of them, right? Okay, so he changed his mind, cosine. Because sine rule doesn't work here. Okay, so why are you choosing cosine rule? Say again? You have two sides and an included angle. Because you have two sides and one included angle. Right. So that's what we have. 23 is one side, 19 is one side. You have one included angle. So how to form an equation for this? We want to find BC, right? And then the angle opposite it is 12. So I will start my equation with BC squared. Okay, BC squared equals to, okay, 23 square. Please complete it, Zafira. 23 square plus 19 square. Yes, you see that this 23 over here and this 23 it appears, 19 and 19 they appear again. So as you practice more writing your cosine rule, you'll be very familiar with it. It is a very simple to apply formula. Okay? Then you'll find BC equals to, just take the square root. Then next question I want to go through is question 14. A. Think about how you will find angle ACD. How to find angle ACD? What do we already have? This one needs one step before we apply our trigo. (180 minus 76). Then what would that give you? Over here I have 22. Which one? Cosine rule? Okay, cosine rule. What is the reason? 3 sides. Yeah, that's it. And what are the 3 sides? You will be interested in this triangle, right? Okay, then you have a choice now. Which length do you want to start with first? Afiq, which length do you want to start with first? 22. Okay, let's see. 22 square equals to, complete the cosine rule. No, change your mind. Huh? Change your mind. Change to what? Correct, okay, then 22 square equals to? Hello? Come on, I only have 2+ minutes left. Change to 41. Good choice. Because we want the side that is opposite to the angle we are interested in. So 41 square equals to, come on, must be fast. 20. 5 square. Okay, faster. Okay. Same numbers, right? We're just repeating. Then cosine C, and we actually call it ACD. Now, then you are able to find one unknown from this equation. Don't write cosine C because in the question they gave you cosine ACD, right? So if this is what you want to write, cosine ACD equals to whatever over something, right? Yeah, you can. But like I said, if you are not good at memorizing, then don't do this. If you are not good at memorizing. However, if you are good at memorizing, yes, you can start with this. So me, not good at memorizing, I prefer to just memorize one equation. Then I will derive myself carefully to get ACD. Yes, Francis? Say again? Yes, you can. Because it is a formula given on page 74. They told you that, hey, you can use cosine A equals to B squared plus C squared minus A squared over 2BC. Yeah, you can. Yes? You mean you want me to show you how to continue, is it? Okay, let me show you. So my next step will be 41 square minus 25 square minus 22 square equals to negative 2 times 25 times 22 cosine ACD. Then I'm just going to divide both sides by this. That means I will get cosine ACD equals to 41 square minus 25 square minus 22 square over negative 2, 25 times 22. You will see that it works out to be the same if you had just memorized the formula. Okay? So with the, we only have a few seconds left. Go ahead and think about 14b. I don't need you to do, just think. Page 77, 14b. Write down again which rule you want to use and the reason. Reason and equation. These are the three things. Then the next one is page 84, question 8a, question 9. Okay, that's all I want you to do to practice. I'm not going to check your work. Just make sure you do this. Okay?